this quadratic modeling problem that I started in class. Kind of losing my voice a little bit here, but I had talked about how, the part about the linearization that they mentioned, that attendance is linearly related to ticket price. So I had already gone through all this part of it and came up with the linear equation that relates ticket price to attendance. But the question that we're asked is, what ticket price would maximize revenue? So if you think about what revenue is, the revenue is the money that they're bringing in. So to find the revenue, you're going to take your attendance and you're going to multiply it by the ticket price. Not the same as profit, so don't confuse it with profit, but this is the actual money that they bring in. So remember that we have an expression right here for ticket price. So if we want to talk about, for the attendance, so that's the attendance. So if we want to talk about revenue, actually, let me call this, I'm going to call this R of X for revenue. Then we're going to take our attendance, which is negative 2,500 X plus 53,500. And we're going to multiply that by the ticket price, which is X. So that's our equation that we get. So we have R of X. If I distribute that, we have negative 2,500 X squared plus 53,500 X. That's my expression for the revenue. And the question says, assume what ticket price would maximize the revenue? Well, think about what kind of graph we have. It's a quadratic, it's a parabola, it opens down. We're going to get something that looks sort of like this. So if we want to maximize our function, then we need to know the value of the vertex. So we're going to take the opposite of B. Now the value of C is 0. So the opposite of B over 2A. So then if you were to simplify this, you get, I already did it, so we get 10.7. So this, but you got to think about what this represents. This isn't the revenue, this is the X value. So this is the ticket price. Oh, actually, that's what we want to know. So the ticket price, if they charge $10.70, the maximum revenue will be, and if you plug this back in to your function, you get $286,225, and that would be the maximum revenue. So I think you have a couple homework problems where it deals with the idea of revenue. So this should help you with that.